right? The function is just currency in the locale module, but because I imported it into this namespace, you have to call the function like this. Here, let's see if I can help if I can just try this quickly. And it's not telling me because I did not close the parentheses. So let's do that. Okay, here's help on the function currency in the module locale. Currency, blah, blah, blah. Formats value according to the currency settings in the current locale. Again, I'm sorry I can't give you a more detailed explanation than that, but that's what I was doing there. Okay.
Okay.
Okay, so working with lists and tuples, we're going to start out just looking at lists. Now, right, so the way you set up these different data structures is really pretty easy and transparent. With a list, you just simply use brackets, and you put the items in brackets, like you see up here. And a list, you can make an empty list, so actually you don't have to have any items at all. Here are some examples of creating lists. So you have items that are values that are certain types, certain primitive data types like integers or floats or strings, and you separate them by commas. Note that unlike a lot of other programming languages, particularly R, it's not particular about whether they are homogeneous. That is, you don't have to have the same data type in a list. For example, you see that here in the movie. We have a string as the first item. We have an integer as the second item, and we have a real number, a float, as the third item. And you can also set up an empty list, as we see in the last example. Okay. Now, lists store items in a sequence in which they are added to the list. So they're a type of data structure that's known also as a sequence. In other languages like R, you would refer to a structure like this as an array. And these would be flat arrays where you just simply have a row of data. But as we'll see later with lists, you can make lists of lists that imitate a two-dimensional array or a three-dimensional array. We'll take a look at that. Okay, so most of the time, a list will have items that are the same data type, but it's not required. Okay, so that's a list. Now, you can use the repetition operator to create a list. So let's take a quick look at that. Right, so I could just say something like scores equal to, and I'll just have a one element list. And then I'll just use the multiplication operator like this. Whoops, that's not it. Like this, and multiply it by 7. And then if we say, well, show me what scores is, right? So scores has 7 zeros. It's a list of 7 items that are all 0. Let's see, here's number 3. Open this up. Right, so this is slide 3, and we're creating these lists, right? And then we're printing them out. So let's run this. If we run this, again, you just see the examples that were on that slide. But now we have these created. So for example, we have temps. If I say, show me temps, temps look like this. Now, this is kind of what I find to be kind of a, maybe not unusual, but perhaps confusing feature of Python. And that is the way you index items. Just like with other programming languages, each item in an array like this would have an index number. For example, in R, this would be number 1, index number 1. This would be index number 2. This would be index number 3, index number 4, and so on. But in Python, as it is similar to other languages that preceded R, I believe, it starts counting at 0. So in Python, this has an index of 0, and this has an index of 1. And that's how you call these items. For example, if I say temps 0, which is the index, it returns the value for the first one. Or if I say temps 3, it returns the value for the fourth one, right? So you're always calling the index plus 1 item. Now, another weird thing it does, though, is that it counts backwards, right? So I could say temps -5, and that calls the first one, right? This is -1 here. Let's do that. Temps -1 is the last one. And again, this takes a little getting used to. It seems inconsistent to me anyway, with starting out with the first item being 0 and the last item being -1, but that's the way it works. So you can access or get, if you will, get the particular value of any item using 2 different indexes, going from the first one with a 0 or going from the last one backwards with a -1. Okay, and that's pretty much what we see here. Now, lists are mutable. And what that means is you can change the values. For example, if we look at, you can both get and set items. If we look at the value of inventory that we currently have, it looks like this, right? It consists of a list with 3 string values. Now, so we can get an item like we've already demonstrated. You could say item equals inventory 2. Oops, inventory 2, and then we say what is item? It is shoes. It's the last one, the third one. That's called getting an item, but you can also set an item. Let's change it completely. Inventory equals staff hat shoes red potion scroll. Notice how if you don't make a syntax error, it will briefly highlight the expression telling you that everything's okay. So if I say, show me what inventory is, looks like this. And so we should be able to set this. Let's try this again. So we're going to set, I think the thing I did before, I'm not sure what I did before, but let's try and set inventory, the fifth item, to a different string. There we go. And so you can see that we have changed. We've changed it from potion, right, to ration. Okay, so this is what I mean, that it's mutable. You can change values. A list has items in the original sequence, and you can change values of individual items. You can't do that with a tuple, as we'll see later. Okay, so what can you do with lists? You can do lots of things. Here are some methods for modifying a list. And again, a method is just simply a function, but it's particular to the object or the class, and we're talking about a list class. So append, as the name suggests, will just add an item or append an item to the end of the list, and it will increase the length of the list by 1. Insert, on the other hand, which takes 2 arguments, will add an item, but it will insert it at the index level, at the index location. Okay, so insert increases the length of the list by 1, but it shifts all the items after the specified index back by 1 index. Okay, remove searches for that named item and takes it out. Okay, so it decreases the length of the list by 1. Index searches for the item, but it returns the index number, the index value for the item. Pop, which is common to other languages as well. If you don't specify an index, note that the index is optional for pop. If you don't specify one, it pops, so to speak, the last item off of the list and removes it. Okay. Otherwise, if you put in an index number, it will pop off, remove that particular item from the list. Okay. So let's look at a couple of these. This is what this looks like, slide 8. Let's see what we have there. And I added some print statements to it so we can see what's going on. In the first line, we just established this list called stats. Then we print it out, show what it is. Then we establish a list called inventory, which was the one I was just playing with. We print it out. Then we append, we use the append method. Note also how you call a method. In Python, it's a little different from some other languages. The syntax is the name of the object dot the name of the method. I guess that's similar to C, maybe to C++. I'm not sure, but it's not similar to R. Okay, so we're going to append this number to stats, which will put it at the end of the list. Here we take inventory and we insert a new string variable robe at the 3rd index, which would be the 4th position. So inventory up here had bread in the 4th position, but now it has robe. Here, let's run this and we can see what's going on. So we're just using the append, the insert, and the remove methods to manipulate these existing lists, right? So that's what we're doing. Okay, and again, the general syntax is the name of the list dot the name of the method. Okay. Pop, on the other hand,